very grateful that we are here to present this topic of handling the impact of biodiesel fuel and lubricants. And before I go on, I just sense that maybe people among you who have attended conferences, other conferences, and maybe you're asking this question: is there anything new that you can actually hear about biodiesel fuel dilution? And the answer is yes. So we're going to talk on a little bit on the engine blow-by, the fuel dilution test that we have included in our experiment, the materials that we use, and we're going to draw some conclusions from it. So this report, we actually got it from this annual energy outlook report, and we see an increasing amount of diesel energy in terms of this British thermal units on the vertical axis being used gradually as we see from the horizontal axis, the time scale from 2004 to 2030. So we actually see an increasing amount of diesel power being used in the market. And there's this study that's carried out by the US National Biodiesel Board, and the test included Cummins ISP, Caterpillar C13, and Mack T12. And the results were acceptable for deposits formation, wear, sludge, and viscometrics, but there's a trend towards higher acid number, and there was also this corrosion and oxidation problems that were mentioned in the report. And for the first portion of our experiment, we actually let me just go through the test materials. The test materials, we have this soil meter, ester, rapeseed, palm, coconut, and we actually took a commercial 15W40 oil off the shelf with its meeting CI4, CJ4 standards. And we have 4 blends, as you can see, we have amine, phenol, amine, and amine. Obviously, these are 2 different amines. Amines plus phenol, and then amines and plus phenol. And also, we also include our these metal deactivators in our test blend. Maybe I just want to touch on this amine and phenol blend a little bit before I go on. Why being some of you here are our customers, why do we always advocate having an amine and phenol blend when we recommend to you? Is it because we just want to sell you more stuff? The reason is, let me just explain a little bit. Amine. Okay, amine actually, and aminic AO, they have actually a higher stoichiometric factor. If you look into the mechanism, you look up the literature for aminic AOs, it goes through a mechanism. There's the pathway. Along the way, there's different transformation products, and at each stage of the transformation, they actually can take care of the proxy radicals. So for each molecule of amine, they can actually take care of several radicals as compared to phenol. Phenol does not have such a high stoichiometric factor. Phenol is different in the sense that phenol it has a higher rate constant. What does it mean by a high rate constant? That means that it has a lower bond energy between, like for example, in the case of phenol, you have the lower bond energy between the oxygen and the hydrogen, as compared to amine, you have the lower bond energy between you're talking about bond energy between the hydrogen and nitrogen. So it actually reacts faster as compared to amine. So phenol reacts faster, but actually amine can take care of more radicals. And the thing with phenol is that if you look into the mechanism, at some point in time it actually donates hydrogen back into the system, and with that you actually help to regenerate an amine. So with that, it is a synergy. So we always recommend theoretically to have an amine and a phenol system, AO system. And this is the conclusion that we can draw from the test. These are the blends that we did in the test that we used in the test blend A, B, D, and E. And and those were the dosages that go along with the blends that we used in our experiments. So in general, we can say that for HPDSC oxidation, we would recommend a blend like our AO blend B. It shows up as one of our better blends in terms of performance. And then for the BIT, again, blend B shows up as a strong performer, but then if you are using, like for example, palm metal ester, for example, it's from Thailand, then blend A could also be of planning is also quite good in this area, in this case. And we like to conclude, the interest in the use of fatty acid metal ester as a fuel is continuing despite the ups and downs that we talked about earlier on. And in terms of lubrication, oxidation, corrosion, it happens, and we have solutions to tackle these problems. And oxidation blends can control oxidation and deposit formation, as we showed earlier on, but the performance and the ability differ in terms of the ability to control these issues. And we also show that corrosion caused by fatty acid metal ester contamination can be controlled by appropriate metal deactivators, and mild corrosion, black corrosion can also be controlled by appropriate